Welcome to the Explainer. Today, we're going to demystify modern software-defined networking. It can seem really complex, but I promise, by the end of this, you'll have a simple and powerful mental map to understand how it all works. So let's get started. This analogy right here, this is the key to everything we're going to talk about. We'll keep coming back to this idea of roads, intersections, and rules to see how these really sophisticated virtual networks are built right on top of plain old physical hardware. Okay, first things first, let's look at the foundation. Before any of that virtualization magic happens, you've got the real hardware, the cables and switches that make up the network. In the world of software-defined networking, we call this the underlay. So think of the underlay as your physical reality. It's the collection of switches, routers, and all the links connecting them. Its health and its configuration, we're talking things like the maximum transmission unit, or MTU, are absolutely critical because every virtual component we build next is going to depend entirely on it. Now, these physical roads, they can be laid out in a few different ways. You might have a more traditional three-tier design, what we call core/distribution/access, or you could have a more modern flat spine leaf fabric. The design you choose for these physical paths, well, that directly impacts how predictably your virtual traffic is going to flow later on. So we have our physical roads. Now, here's where it gets really interesting. How do we build a flexible virtual world on top of that rigid hardware? Well, that brings us to the overlay, which is a whole new layer of networking. A huge limitation in traditional networking has always been the number of separate, isolated networks you can create. The technical limit on VLANs is just over 4,000. So what happens when you're, say, a cloud provider or a huge enterprise, and you just run out of VLANs, but you need thousands more isolated networks? And the overlay is the elegant solution to that problem. It creates these virtual tunnels that run right on top of the physical underlay. This lets you create tens of thousands of logical networks without ever needing to touch the physical switches or assign a new VLAN. It's a brilliant example of software just abstracting away physical limitations. So here's the crucial point, right? The underlay provides the physical path, the actual roads. The overlay, on the other hand, creates the logical, isolated networks that your applications actually use. They are two totally distinct but completely dependent layers. You just can't have one without the other. All right, so we've got our physical roads and our virtual tunnels running on top of them. Now, let's look at the rules of the road. How does data actually move through this two-layered system? We generally think of traffic in two main directions. East-west traffic is all the communication happening inside your data center, between your applications. North-south is the traffic going out to or coming in from the outside world, like the internet. And yeah, they each have very different design goals. Following a single packet of data makes this crystal clear. Okay, so it starts at a virtual machine and enters its logical network segment. If it needs to go to another network, it crosses a logical gateway. Then, and this is the cool part, it gets wrapped up or encapsulated with a new header so it can travel through the physical underlay inside a tunnel. Finally, it arrives at the other end and gets unwrapped at its destination. Simple as that. So those gateways we just mentioned, yeah, those are your software-defined routers. They act as the intersections and, really, the traffic hops of this virtual world. They connect your logical networks together and they enforce the rules about where traffic is allowed to go. Which brings us right back to our road analogy. Building this virtual map is incredibly powerful. But what happens when things go wrong? When you hit a detour or take a wrong turn. Understanding the common pitfalls is the absolute key to troubleshooting these environments. So imagine this situation. You're seeing packet drops or maybe just slow performance, but it's totally inconsistent. It works for some virtual machines, but not for others. This is a classic and super frustrating symptom in software-defined networks. So why does this happen? Well, it happens because the issue you actually notice, like a web server not responding or an application timing out, is happening up here in the logical virtual layer. It's an overlay symptom. But the actual problem, the pothole in the road that's causing all the trouble, that's frequently a misconfiguration or even a physical failure hidden down in the physical network that the entire overlay depends on. The problem's in the underlay. And these are the classic wrong turns. A really common one is an MTU mismatch. This is where the data packet, after it gets encapsulated, suddenly becomes too big for the physical path it's trying to cross. Another big one is asymmetric routing. That's when traffic goes out one way but tries to come back a different way, which can completely confuse security devices like firewalls. And here's a pro tip for you. If a problem isn't affecting everything, it's very likely not some universal policy error in your virtual network. It's probably a physical issue, like a bad cable or a misconfigured switch port on a very specific path in your underlay. Now, for those of you studying for certifications, this is what you really need to take away. You want to focus on understanding these core concepts, how traffic flows, what the common failure points are, not just memorizing random trivia. Being able to sketch that path is the real goal here. So, what we've done today is we've basically built the legend for your mental map. We've defined the physical transport, the logical overlays that ride on top, and the routing rules that connect them all together. You now have the framework to understand almost any software-defined network out there. And this leaves us with a final, really crucial thought. The most advanced, feature-rich virtual network in the world is only as stable and as reliable as the physical roads it's built on. Knowing how to see both of these layers, the physical and the virtual, well, that is the real key to success. Thanks for joining this explainer.